Okay, in this video, we're looking at chapter 6, section 3. We do not have a video for section 2, so don't worry, you're not missing it. We don't have one. And we're looking at polygons and angles. So you have the St. James heading, and then you underline and you write chapter 6, section 3, and then underline and write and underline polygons and angles. Some of this is going to be a review, but some of this will be new. So here we go. Okay, the sum, write this down. The sum of the measures of the interior angles of a polygon is this. This is a formula. You need to know this. You definitely want to know this formula. Where n, here's n right here, represents the number of the sides in a polygon. Okay, and we're going to go through a ton of examples, but this is a formula. So here is the formula just written out. S means sum. So when you add up all the interior angles, the sum, there's a nice formula for that. N minus 2, you do that first, and in parentheses, you do that first, then times, multiply 180. Okay, and that's going to give you the sum of all the interior angles. So S just means the sum of all the measurements of an interior angles. Okay, so let's do some examples, just so you know what that means. Let me show you what we're talking about. So if I have, okay, I have this pentagon, okay, and I want to find out if I add this angle, this one, 1, plus this angle 2, plus this angle 3, plus this angle 4, plus that angle. If I add them all up, what's the sum of all those interior, because they're inside, interior angles? That's what I want to know. So S would be the sum of it, n minus 2 times your 180 degrees. That's just the formula. So just know the formula, memorize the formula. Okay, n is the number of sides on your polygon. So how many sides do I have? 1, 2, 3, 4, 5. I have 5 sides. So n, in this case, n is 5 because it's a pentagon. Okay, so I'll do S, I'm looking for S, is 5 minus 2 times, just these parentheses just means once you're done, everything inside it, you multiply, times 180. Okay, so 5 minus 2 is 3 times 180. Okay, and of course you know me. Do I have my calculator with me? No. So on the side here, I'm just going to do 180 times 3. Okay, that's 540. So S, the sum of all interior angles, oops, is 540. Trying to get this out of the way. Okay, so this is 540. Okay, degrees. Okay, so that's all you do. You just plug in, once you know what n is the number of sides of your polygon. The number of sides is 540. So let's try another one. So it says find the sum, that's your S, of the angle measures of each polygon. So we did a pentagon. Let's do another shape. Let's say we do, okay, so we do a hexagon. Okay, so here's this hexagon. And so we're looking at the interior angles inside, okay, inside. What would be, if we had to add up all of their angles, all of the measurements there, well, instead of doing all that math, we'll just do the formula, n minus 2 times 180. But n is the number of sides. So how many sides are there? Let's see here. 1, 2, 3, 4, 5, 6. So n is 6. Okay, so let's do the math. 6 minus 2. Of course, you write the formula first. Whoops. And then you solve. Write the formula, substitute, and then solve. So now we have S equals 6 minus 2 is 4 times 180. 80. Okay, so on the side here, because again, sister doesn't have a calculator with her. Okay, and we get 720. Okay, degrees, and that would be if you added up all of your angles, all of the angles of a polygon. Get down. Okay, we're gonna do that in a minute. Let's try another one. Okay, let's try another one. So let's say I do, okay, say I do an octagon. An octagon is this shape right here. So let's see. Again, we're looking at interior angles, inside. If we added up all of their measures, so this one plus this one plus this one, whatever the measurement it is here, if we measured this angle, if we added up this measurement, what would that all equal? So instead of doing all of that math, we're going to use the formula. S equals, yes, you write it every time, every single time. So on the test, I don't have to give you the formula because you've memorized it because you've written it every time. See? All right, now let's count our sides. N is the number of sides. So 1, 2, 3, 4, 5, 6, 7, 8. So it's an octagon. Okay, so there are 8 sides. We did a hexagon up here. Okay, yes, you need to know that octagon's 8, hexagon's 6, pentagon is 5. Yes, you need to know that. So S equals 8 minus 2. And then once you do that, you multiply by 180. So S equals, what's 8 minus 2 is 6 times 180. So again, you do this on the side. I don't need to see this. Okay, so the sum, when you add up all those angles inside there together, you get 1080 degrees. 1080 degrees. Okay, now in theory, if you're given what the total number of the measurement is, but you want to know, okay, what's the measurement of one angle inside? So if you want to know the measurement of one angle of one of those interior angles inside, what would we do? Well, let's bring back the octagon from it. We just did this octagon, and we found the sum of all the interior angles. So every angle, if you add them all up together, it was 1040. Okay, that, or 80, sorry, 1080. If you add up all the angles, that is the measure of all the angles together. But what is the measurement? What's the measurement of one angle? 1. So if I want just one of them, how do I find the measurement? If I wanted to measure just this one angle here, what's that measurement? How do I figure that out? I know that 180, okay, S means that's the total. That's the total. What do I find for just one though? Well, to do just one, you would actually just take this information, 180, and divide it by 8, by the number of angles. So I can figure out for one angle. Okay, so again, on the side, okay, we roll around to the nearest tenth if necessary, if we have to do that. Okay, so 3 gives us 24. Okay, so that means for an octagon, okay, one angle, the measurement for one angle, so the measurement of one angle is 135 degrees. This M just means measure. M just means measure. That if I had to measure it, if I took a protractor and measured one angle, so the measurement of one interior angle is 135 degrees. So that means this is 135, this is 135, this is 135, whoops, 135, that's 135. 135. That's 135. That's 135. And that one's 135. And that one's 135. I'm running out of room. Okay, each of those are 135 degrees. And if you add them all up, you get 1080. Okay, so one interior angle is 135 degrees. Let's go back to that hexagon that we did. Okay, we made a hexagon and we found out that the hexagon, all of the angles together were 720 degrees. So this one plus 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 that one was 720 degrees. Okay, but what's the measurement of one angle? What's the measurement of one of the angles? Okay, so we're going to take 720 degrees and we're going to divide it by how many angles? 6. We're going to divide it by 6 because there are 6 angles and we want to know how much it is for one. So 6 on the side, this is the math I don't need to see. 6 into 720 goes once. You get, okay, so each angle for a hexagon, okay, the measurement of one angle is 120 degrees. Okay, 120 degrees. So that means this is 120, this is 120, this is 120, this one's 120, this one is 120, and that one is 120. Okay? And again, if you took all those 120s and you added them up, I don't know why you would do this when you have an awesome formula that does it for you. Okay? Here, if you add them all up, you're going to get that number. And that's how we got that number. We just used a formula. If you remember from the, if you look above in your notes, we just used a formula. Okay? Since we didn't know 120 off the top of my head, I don't know off the top of my head that a hexagon's interior angle is 120. So we have a nice formula that gives it to us. Okay? Here's a fun thing that your workbook and textbook does. If when you get to really big polygons, you know, if there's 24 sides or 19 sides or 14 sides or 11 sides, they just write this, 11 gone. Because the name for an 11-sided polygon is really long, so instead of doing that, they just write, okay, here's 11 gone. Now we also don't have to memorize what 11-sided polygon's name is. They're just telling you this means there's 11 sides. So if you had to draw a shape, it's 11 sides. Oh, okay, that's a horrible drawing, but that means 11 sides. That's a horrible drawing, though. So if I wanted to find the sum of the interior angles, you would do n minus 2 times 180. Okay, so it's 11 minus 2 times 180. Okay, 11 minus 2 is 9 times 180. Okay, hold on. So you do on the side 9, 0, 2, 7. Okay, 620. Okay, so S is 620. So again, that's the sum of all the interior angles. But now if I wanted to know the measurement of one of those angles, measurement of one, to emphasize just one of the angles, we would still do, we have the 1620 now, and we divide it by how many angles that figure had. It had how many angles? It would have 11, because if there's 11 sides, there's 11 angles. So 11. So again, on the side here, and we round to the nearest tenth if necessary. So 11 into 16 goes once. Let's get 11, subtract 52, because there's 44, subtract. Okay, you need to borrow 80, I'm running out of space. 77, okay, definitely running out of space. So I get 30. That's supposed to be a 30. So it'd be, okay. So the angle, the measurement hold on, now I lost my number. 147.2 degrees. I rounded. Okay, so for an 11-agon, I don't know the name of that either. Okay, the measurement of one angle is 147.2 degrees. Okay, so when you see 11 dash gon, that just means it's a 11-sided polygon, or 19 dash gon. It's 19-sided polygon. Okay, so I want you to, for the problem for next class, I want you to find the sum of all the interior angles, so that's your S, and find the measurement of one angle that we just like we did a minute ago. So, okay, here is your, okay, here it is. If I give you 12 agon, what is the S? Find the sum of everything, and then find the measurement of one. Okay? See you next class.